Math 3, Unit 4, Section 6. Today we're talking about graphing rational functions. Okay, and while this looks kind of weird, it actually is relatively not difficult, and we're going to walk through it all. Okay, couple things. We've been doing translations this whole entire year. Okay, so when we have something like this where we have the f of x plus c, how is it translating? What is happening? Very good. It is going up. Okay, so it's going c units up. When we have a minus c, it's going c units down. Very good. Down. Here, what's going to happen? Left. Very good. It's going to go c units left. Because remember, whatever's in parentheses, it becomes opposite. Very good. And so this one will end up going northwest. Right is correct. This is one that some of you sometimes forget, but when you have the negative in front here, that means it's going to reflect which way? X-axis. Very good. And when the negative is inside like that, it's going to be the y-axis. For some reason, I always feel like it should be the opposite, and that's how I remember. It's kind of the opposite of what I think it should be. But. Okay. On this problem, okay, this right here is the graph y equals 1 over x, and there are two asymptotes, and we've talked about asymptotes in this class as well. There is an asymptote here at x equals 0, and there's also an asymptote at y equals 0. Okay? If you notice the graph, remember with asymptotes it gets really close to that value, but it never actually touches that value. I'm going to rewrite this equation to show you where the asymptotes are actually coming from. What is an asymptote? So it's basically an imaginary line, which is why we do the dotted lines, because it's actually not a line that you would draw. Okay? And it means that the graph, the lines get really close to it, but they can't touch it. To me, I think about it as like a magnet, and you know how when you have two magnets and you're like pushing the two positive ends together and it just keeps reflecting a little bit, they never actually touch. I think of asymptotes in that way, like it's almost like there's a magnetic field and it gets close to it, but it can't actually touch that. Okay? So it's like keeping your graphs in an area. It's keeping the graph in here and it's keeping it in here. It's like a boundary. Okay? If I rewrite this equation right here, y equals 1 over x, it really is y equals 1 over x plus 0 at the end. And so the x plus 0 would be one that where you would like set it equal to 0, but that would just make it 0, right? And so that's how you get a vertical asymptote for x equals 0. And then the horizontal is the value at the end for your y, and that's y equals 0. So that's where the asymptotes came on this equation. Thank you. How are you? I'm good. How are you? Okay. Stop, please. Okay. So if we go down to this other graph, oh, and before I do this, I want you to write this at the top of your paper as well. When you're doing your homework, you can always go to desmos.com and write in your equations and be able to check your solutions. And at the end of class, if we have time, we'll go there and check things. Okay, but this will show you the graph and if you did it correctly when you type in your equation. Okay? So, we need to sketch the graph and then find out all this information. Okay, I like to always start with my asymptotes. So, where would be my vertical asymptote?
2, 1. Are we negative 2 or 2?
So, your vertical asymptote, we have our vertical and we have our horizontal, right? Okay, so my vertical asymptote is with the x because it's going through the x-axis, which is making a line. And so if you go down here, the vertical asymptote on this one will be x equals 2 because we would set this equal to 0 and we would get 2 for the value. Okay, so x equals 2. I'm going to use a highlighter to draw this in. You can just do a dotted line. If you want to grab a highlighter from me, you can. There's some in the pencil box. Okay, and what would be my horizontal asymptote on this one?
1.
Y equals 1 is correct. And again, that's coming from the value here at the end. That right there is your horizontal asymptote. Okay? The vertical asymptote came from down here. So my horizontal, I'm going to go up to y equals 1, and I am going to make that dotted line through there. Okay, any questions up to this point? All right, so now we want to find the Y-intercept. Does anyone know how to find the Y-intercept?
Since you create equal to 0.
Close. Okay, what you do is, excuse me, very good. You plug in 0 for X and solve for Y. And I would make sure to write that note in your notes packet so that you can remember what we did in order to do this. So Y-intercept. If you look back at this equation, f of x is the same thing as writing a y. So we're going to plug in 0 for x and solve for y. So we're going to rewrite this equation. Y equals 1 over, but instead of writing x, I'm going to write a 0. 0 minus 2 plus 1. And we're going to simplify it. Okay, and so what is 0 minus 2? Negative 2. So we have negative 1/2 plus 1. And what does negative 1/2 plus 1 equal?
Negative 1/2.
A positive 1/2, right?
Yeah.
If you need to, you could get a common denominator. And so I'd end up changing this to be 2 over 2. The negative, I don't want it with the bottom. I would move the negative up with the top here. So that'd be a negative 1 up there. And then negative 1 plus 2 makes 1. So 1/2. What is that as an ordered pair?
0, 1/2.
0, 1/2. So we're going to go to our graph now and we're going to plot that on there. 0, 1/2 is right there. What do you think I'm going to do to find the X-intercept?
Set y equals 0.
Plug in 0 for y and solve for x. So again, we go to this equation, but this time I'm going to plug in 0 for y. Very good. 0 equals 1 over x minus 2 plus 1. Now, just like we've been doing this entire unit, we need to figure out what is our LCD, and because I have an equal sign, I can eliminate my fractions by multiplying by the LCD and solving. What would be my LCD? X minus 2 is correct. It's always a good idea to always check your extraneous solutions as well. So what are my extraneous solutions? Everybody needs to be writing this down. X cannot equal 2. So now what do I do? Now that I know my LCD, what do I do? Very good. Multiply every single term by x minus 2. What is 0 times anything?
0.
0 equals, do I need to make this bigger? Okay, 0 equals, and then what happens? X minus 2's cancel, and I'm left with 1
plus x minus 2.
plus, and we're going to distribute 1 times x makes x, and 1 times negative 2 makes. And then all we're going to do is solve for x. So we're going to simplify. What is 1 and negative 2 equal?
Negative 1.
0 equals negative 1 plus x. And if I want to solve for x, what should I do next?
Add 1.
Very good. Add 1 to both sides, and therefore, what does x equal?
1 positive. And it's
What would that be as an ordered pair?
0, 1. No, it'd be 1, 0.
X equals 1. So that means 1 goes in the X spot, 0 in the Y, which is what we did. We plugged in 0 for Y, solved for X. Okay? So let's plot that on our graph. So 1, 0. 1, 0 is right here. Now, if you go back and look at our original graph here, when you're dealing with rational functions, you'll always have two asymptotes, a horizontal and a vertical, and your curves will always be diagonal from each other. So you'll have, if you have one in quadrant 1, you'll have one in quadrant 3, diagonal from each other. If you had one in quadrant 2, then the other one would be in quadrant 4. Okay? Can you tell where my graphs are going to be here?
Yes.
Which quadrants?
3 and 2. Wait, I thought
3 and 2.
No, it's 4 and 2. 1, 2, 3, 4.
Albert. Sure. I prefer you to wait till we're done with notes. If you can wait. If you can't, then go sign out and go.
Miss Allison, what was the
Oh,
question?
3 and 1.
Yeah, what quadrants do you think this graph is going to be in?
It's
1 and 3.
1 and 4.
1 and 3. Do you see how you have these points right here?
No.
Oh.
We just marked these points right here.
It goes like this.
And then it's diagonal. Or you can say top right, bottom left.
How do you know? It goes 1, 2.
Oh, so quadrants, just so you know, this is how it goes. It goes 1, 2, 3, 4. That's how the quadrants are labeled.
Is it bad I never do that?
You should know it, but
Oh, I thought it was just
Labels you
3.
as dumb.
It's just my dad has been on my
okay.
Oh, really?
All right, are we good here? So, domain. This again goes back to the beginning of the year. Domain is your X values, right? Correct? We can put X here, and next to the range, it is our Y values. Now, if you're going from left to right here for the domain, what value will I start with? Negative infinity. Now, it goes until this asymptote, it will not touch this value. So for the domain we're going left to right. Where does it stop at? Good. 2 with the parenthesis, because it will not equal 2. It'll get really close to 2, but it will not equal 2. And then we do our union, and it starts back up again at 2 with a parenthesis and goes all the way to positive infinity. On these graphs, your domain will always be written like this. It'll go negative infinity until you get to your asymptote, whatever that value is. Yeah, and then 2, and then going to all the way to positive infinity. So whatever that asymptote is, those are the values that goes on this side. Alexis. The 2 is from right here, from where it... So how this goes, it stops at 2. This value is 2. That 2 came from my vertical asymptote. Did I answer your question? Do you remember where I got the value of 2 originally? Does anybody remember where I got this vertical asymptote of 2?
Yeah, at the very beginning, X minus 2.
Right here, from the denominator of the fraction. Okay, my range, it's the same thing except for we're doing our Y values. What is my smallest Y value?
Negative infinity.
Negative infinity. And then where is the asymptote? Where does it stop at? 1. And then it'll be the union, and it starts up again at 1 and goes all the way till positive infinity. Okay, do we have any questions about that? Okay, going down, it says state the intervals on which the graph of f is increasing. So remember, graphs, you read left to right. If you start at the left, this is going down. Is that increasing? No, down is decreasing. Then you go up to this point and see it's going down again. So is it ever increasing?
No.
No, so this one's none, or you can write 0 with a line through it for no solution, but it doesn't ever increase. Okay, then it says, state the intervals on which the graph of f is greater than 0. Whenever you're talking about 0, you're talking about your x-axis. So when is it above 0? When is it above the x-axis?
Always.
No. Here it's below the x-axis. Okay, so what is the interval?
For 2, 1. No. Yeah, 1 and
Negative infinity 0.
Negative infinity till
It's to 1.
to 1. So it's above 0 is our x-axis. Okay, this right here, this line right here, the x-axis, that's your 0 mark. It is above 0 from negative infinity until you get to 1. And you use a parenthesis. And then it's a union. And do you see how this whole one is above 0? So where does this start at?
1.
No.
2.
2 all the way till infinity. Okay, so Matt, what's the answer? Negative infinity to 1 and also 2 to infinity because it starts up again. This is still above 0. Okay. Ask me any questions about this problem. Anything that you're like, I still don't understand where you got that number. Okay, let's move on.
Could we not have they're not that hard, but it's a lot of work.
Okay. You don't actually have to worry about reflections very much, but I want you to know that this right here means it is a reflection, but the way we work it out, you don't even have to think about it, okay? When you start with this, with your graphs, I think it's always easiest to start with your asymptotes. So, what will be my vertical asymptote on here? So we set our denominator equal to 0, and my vertical asymptotes are x equals negative 2. So we go to x equals negative 2, and we make our asymptote there. What will be my horizontal asymptote? Y equals negative 1. And that value just came from the number here at the end. Y equals negative 1, and we're going to go and make that dotted line. Jake, are you getting this? Okay. Now, how do I get my y-intercept of the problem? Very good. So we know this actually means y equals. So we keep the y and we plug in 0 for x. So I have y equals negative 1 over 0 plus 2 minus 1. What is 0 plus 2? So negative 1/2 minus 1. When you have two negative values, what do? Add them, and it stays negative. Okay? If you want to, you could change this to be negative 2 over 2 so that they have like denominators. And when you add that, you get negative 3 over 2 or negative 1.5. To me, negative 1.5 makes more sense. What would that be as an ordered pair? 0? No. Yes. Negative 1.5. So 0, negative 1.5. Where do I go? In English.
Negative 1.5.
Yeah, we go down, negative 1.5. Make our point.
Is that like a serious question? Where do you go?
Down. Down, up, right, left, which way? Okay, now, can you tell where that curve should be now?
Yeah.
We should not have out cell phones right now. Yes. 2 over 2 reduces to be 1. So because this has a denominator of 2, I want this to have a denominator of 2. And so like if this had a denominator of 5, I would have written this as 5 over 5. Is that better? Okay. This is not going to touch the x-axis because it has that asymptote right there, right? And so that curve is done. Now I'm going to have another curve up here. Do you guys agree? But it's probably going to cross the x-axis, so I don't want to draw it yet. But they're always diagonal from each other. So we have one curve done. We're going to get this curve. But first I need to find the x-intercept. How do I find the x-intercept? Good. So 0 equals -1 over x plus 2 minus 1. What will be my LCD? What would be my extraneous solutions? X cannot equal -2. Which would make sense. Do you see how -2 is already an asymptote? Okay. So we're going to go through and multiply every term by x plus 2. Ryan, are you getting this? Please write this down. Okay. What is 0 times anything? 0. X plus 2's cancel and I'm left with -1. We now are distributing -1. What is -1 times x? -1x. What is -1 times 2? -2. Now we're just solving for x. What do I do to solve for x? Combine like terms. Okay, so we get 0 equals, what is -1 and -2 when you add those? -3 minus 1x. And then what would I do? You could add 3. I'm going to add x because then that'll make my x positive. You could do it either way. If you add 3, you're just going to have an additional step. So I'm going to add x to both sides. So that cancels out. And I get x equals -3.
Wow. That is amazing.
How do I write that as an ordered pair? That is my x-intercept, -3, 0. So at -3, 0, I make my point there, and then we can draw our curve in. Any questions? Okay, what's the domain?
Negative infinity, comma -2, -2, comma infinity.
Okay, Max. No more talking. You know it. You're good. Okay, somebody else tell me the range.
It writes the negative infinity.
Okay, Kyle, let's hear it. Negative infinity to what?
-1.
To -1. Perfect. Okay. Is anybody unsure of where they got those values? Okay, then I'm going to pull sick because everybody knows nobody raised their hand. So when I pull a sick, I want somebody to explain to me why the domain is what it is. I have to choose the right class. So, why is this? Isaac, why is this the domain?
Because of math.
Okay, no.
No, that's definitely right.
So, domain starts at the left,
Oh yeah, it goes.
negative infinity, and then what happens right here?
Kind of stops.
It stops because of the asymptote, which is why there is a -2. So that's why we stop here at -2, and then it starts, the graph starts right up again at -2 and goes all the way to positive infinity. Make sense? Okay, so I'm going to ask the same question again. Why is this -2 value here? How do I know this? Okay, Alexis, how do I know this? Why is the domain this? Beautifully restated, thank you. Okay, now my next question is, Why is this range this way? Why is it stopping at -1? What is happening? Why is the range this way? Wyatt. Why is the range that? Why does it stop at -1? Because why? Not the point. What is this? The asymptote. So it goes from -infinity, it stops at the asymptote, which on the range is at -1, and then it starts back up again. Okay? Good job. All right, so looking at this graph, if we read the graph from left to right, when is it decreasing? Is it ever decreasing on this one? No, because you start left to right, this is going up. Up is increasing. Then you go to this point, it keeps going up, it is increasing. Therefore, it never decreases. So none or no solution. You start left to right, and if you go like this, it's going up, and then you start here, and it's going up. Okay? Now, it says state the intervals on which the graph of G is less than 0. Where is it below 0? So remember that right here, this is my 0 line. Do you guys see that?
Yep.
Okay, so when is it below that?
At -3.
Good. -infinity till -3. And then where does it start up again below 0? Do you see right here? At -3 is where it goes above 0.
But shouldn't that be at the end? Since we're going bottom to top?
Yeah. Go
So it should
right.
be -infinity, comma -1, union -1, -3.
This is not talking about the domain. It's talking about when is the graph below 0. Okay? So hold on. When we're talking about 0, we're talking about the x-axis. So I'm going to take all the rest of that off. These values are below 0. This, starting from the left, is -infinity, and at 3, it goes above the x-axis. Or at -3, it's going to go above 0.
So does it start at -2?
Yes.
-1.5.
So then it starts up again at -2 to positive infinity, is where it's below 0.
Skip the half thing.
I did, because this right here is above 0. The 0 is always your x-axis. So the x-axis, anything below the x-axis is here. One of your test questions will also ask you, when is it greater than 0? Could you tell me the interval of when it's greater than 0?
No, thank you.
The only time it's greater than 0 is from -3 to -2.
Would it be with the bracket?
No brackets. Because when it's at 0, it's equaling it. So it's not greater than or less than, so it'd always be a parenthesis. Okay. This next part, I'm hoping, will be easy. All you need to do is state what is your vertical asymptote for these problems and what is your horizontal asymptote.
That's it, sweet.
Good. So if there's no plus, there's actually something actually adding there.
A 0. Not a 0.
So I'm going to give you about 30 seconds to write down each of these answers. Maybe a minute. Kyle, on your own, write the answers, please. Okay, so I'm going to pull some sticks. If you want to check your answers in your group really quick, see if you guys all agree, and then I'm going to ask you for help.
Keep her going.
Keep her going, eh? Just keep her going, big. Hockey stick, eh? I'm going to take one.
Sure. Talon's going to come up and do h of x.
Oh, sweet. Can I do the other one?
Do you just want to write the number or the parentheses?
You need to write it as an equation. So like x equals this, y equals this.
Okay. Just give me a second to think. Hold up. That.
Perfect. Do you guys all understand where he got those numbers from? Okay, so real quick, I'm going to pull a stick. You can get a candy. Keithel, how did he get those values?
What the heck? Can I get candy for this? Okay.
How did he get these values? Where did they come from?
So, because negative 5 plus 5 equals 0.
Okay, so you set that equal to 0 to get the negative 5, and then?
And then since there's no plus or minus thingy behind it, it's just 0.
Perfect. Great job. Thank you.
I get a candy?
Sure. Okay, who wants to come up and do the next problem? Sam.
Yeah, that was a horrible thing you said, dude. Is that what you're talking about?
Okay, perfect. Thank you. You get candy. Okay, and explain to me how she got those values. Okay. Jenny. How did she get 7 and 4? Denominator set equal to 0 for your vertical, and it's just going to be y equals. Very good. Okay, moving on. Last one. This one is slightly different. You have a test question just like this one and the previous ones we did. You'll notice here, this one they want you to solve this graphically, and this one they want you to solve it algebraically. We're going to start by solving it algebraically. Okay? So, it says f of x equals g of x. Here's your f of x and g of x. How do I write that? Very good. 2 over x plus 1 minus 3 equals negative 2. What would I do in order to solve for x here? What would I do? Okay, so we can multiply everything by the LCD, or I could add 3. What do you guys want to do? Okay, we'll add 3 first. 2 over x plus 1 equals 1. Now what will I do? Okay, what is my LCD? Albert, you getting this? What are my extraneous solutions?
Negative 1.
X cannot equal negative 1. Good. So what do I do now? Good. Multiply x plus 1 to every term. And what happens? X plus 1's cancel out and we get 2 equals, and we go 1 times x is x, and 1 times 1 is 1, and what do I do? Subtract 1. And so 1 equals x. Okay, there is my answer algebraically. Now we need to go over here and do this graphically. Okay, so again, I'm going to rewrite f of x equals g of x. I'm going to do it up here so I have a little bit of room. Okay, so 2 over x plus 1 minus 3 equals negative 2. What do you think I need to do in order to graph this?
Set your asymptote.
Yeah, but before that, because this needs to be set equal to what?
0.
Probably 0, okay? Because, and so exactly, we are going to add 2. So when I do that and I rewrite it, I have 2 over x plus 1, and then what is negative 3 plus 2? Negative 1. And we can put equals 0 or equals y. So what are my asymptotes? What is my vertical asymptote? X equals negative 1.
Oh, yeah.
X equals negative 1. Draw our vertical asymptote. Set the denominator equal to 0. We get x equals -1. What is my horizontal asymptote? Y equals -1. Where did that come from? The y equals -1 came from right here. Okay? So y equals -1, we go and we draw this. Okay. We already found our x-intercept, didn't we?
Yeah.
What is it?
1.
X equals 1. So we know there's a point right there. Oh, wait. Not 1. No, it is 1. Okay, sorry.
I know it is.
And so I'm just going to draw the graph there. We could find our y-intercept as well, but we're just going to worry about this right now.
That is a really ugly dog.
Thank you.
Miss Alto, that dog's beautiful. Don't listen to her.
Just the way it is.
Okay. Now, C says, explain the relationship between your answers in A and your answer in B. Your answer in A right here, that is a point. A point is always written as an ordered pair. What is that as an ordered pair? Okay? I basically just told you how to explain this. Okay? But I'm going to write it out as a complete sentence. Okay? The solution on the graph is an XY coordinate. Or you could say the solution on the graph is an ordered pair, or something about it that it's basically two numbers, okay? Where the solution in part B is only the x value.